Hi there, this is A-Level Physics. What I'm going to do on this one is do a I'm going to say a couple, but three free-fall and projectile motion questions, and then I'm going to do another two in a second part video. So basically, if you want to have a go at the question, pause it, have a go, and then what I'll do is take you through the full solutions. Okay? So question one, a ball is dropped from a 10-meter high bridge. Calculate the amount of time it takes to land. So on a question like this, we need to do the equations of motion. So we need to write suvat. If you've not done this, then you need to go back and look at the equations of motion videos that I've done. So suvat, and the ball is dropped from a 10-meter high bridge. So the ball, we can safely establish, is moving downwards. So what I'm going to do is take down as positive. So the displacement vertically downwards is 10 meters. The initial speed, the ball is dropped. So we can safely say that that would be 0 meters per second. The final speed, I'm not sure what that is, and I don't need to know. The acceleration is the acceleration due to gravity, which is 9.81 meters per second squared. And then we're going to calculate the amount of time t. So in this instance, we need an equation of motion that hasn't got v in it. So if you're not sure what the equations of motions are, you need to have a look at your respective data sheet, or you need to go back and watch my videos on projectile motion and the equations of motion. So an equation without v in it would be s equals ut plus half at squared. And the initial speed is actually 0, so that cancels out. So the displacement is equal to half at squared. And what we're going to do is rearrange to find t. So multiply by half, so that'll be 2s equals at squared. And then we need to divide by the acceleration to get the time, and obviously square root. So 2s over a square rooted is equal to the time. So the displacement s is 10, so 2 times 10 is 20. Divided by the acceleration due to gravity, 9.81. Square root will give us the time taken. And you should have got a time that is equal to 1.43 seconds. Hopefully that one went okay. Let's have a look at another one. So this one is actually much more challenging. If you want to have a go at this one and get this right, then that's very impressive. So if you want to pause and attempt this one, and then I'll take you through the full solution. So a ball is thrown from a 10-meter high bridge, so the same scenario as last time. However, this time, whoever's throwing the ball, to make this a lot more difficult, has decided to throw the ball downwards with a vertical velocity of 2 meters per second. So what we're going to do, what I'm going to show you, is how to calculate how long it takes the ball to hit the ground. So I'm going to do suvat yet again. So suvat. So the displacement, we're going to take down as positive as well. So the displacement vertically downwards is 10 meters. The initial speed this time is 2 meters per second. The final speed, I'm not interested. The acceleration is acceleration due to gravity, 9.81 meters per second squared, and the time is t. So what we actually need to do is to use an equation without v, so that would be s is equal to ut plus half at squared. Although this time the initial speed is not equal to 0, so it makes it a little bit more complicated. But what we need to do is simply put in our values. So the displacement will be 10 meters. The initial speed is 2 times t, plus half of the acceleration. So half of 9.81 is 4.905 lots of t squared. So what you should be looking at, especially if you do mathematics or you did really well at GCSE maths, is that this is actually a quadratic. So we can use the quadratic formula. So let's just rearrange this. So it's 4.905 lots of t squared plus 2t, and then minus the 10 equals 0. So I'm just going to switch colours. So that would be A, this would be B, and this would be C. So if you can remember if you didn't know any of this but you want to have a go at it now, I suggest you use the quadratic formula or look it up and use it. For those that can remember it, it would be minus b plus or minus b squared minus 4ac, and that's square rooted, divided by 2a. And then we just need to put our numbers in. So minus b would be minus 2, plus or minus. So we've got b squared, which is obviously 4 minus 4 times 4.905 times minus 10. But because it's minus that, then we've got a minus, which would obviously give us a positive value. So that would be minus, which is a plus 196.2, all divided by 2 lots of A. So 2 times 4.905 is 9.81. So we're going to do minus 2. So minus 2 plus 4 plus 196.2 equals, so that's 198.2. And then we need to divide that by 2 lots of A, which is 9.81. So that gives us, square root. That gives us 1.24 seconds. Which sounds right, it is correct if you got that, well done. But really, the question that I did before was, 1.43 seconds. So it would be, logically, if we've thrown it downwards with a little bit of initial velocity, then the time should be less, which it is. So well done if you got that. Let's do one more question just to finish. So if you want to have a go at this next one. So question 3, if you want to pause and have a go at this one, and then I'll take through the answers. So a ball is thrown vertically upwards at 20 meters per second. We're going to calculate the maximum height reached by the ball and the time taken for the ball to hit the floor. So if you want to have a look at this one. So again, we're going to do SUVAT, but this time the ball is being thrown upwards. So what I'll do is take up to be positive. So the displacement, that's part A, we're trying to find that out. The initial speed is the vertical speed upwards, which is 20 meters per second. And the final velocity, so when the ball reaches its maximum height, it's obviously going to stop moving vertically, so its final velocity is 0 meters per second. The acceleration is the acceleration due to gravity, but it is negative, so that's minus 9.81 meters per second squared. And time, we'll figure that out after, because part 2 asks us to find the time taken for the ball to hit the floor. But what we're going to do is to find the time it takes to reach its maximum height, and then you can simply double that, the amount of time it takes to reach its maximum height, which will give you the time to fall as well. So let's look at this first bit, maximum height. So we need an equation without t in it. So the equation without t in it is v squared equals u squared plus 2as. And what we need to find is the displacement s. So that would be v squared minus u squared equals 2as. And then what we need to do is obviously get rid of the 2a, so we need to divide. So that'll be v squared minus u squared divided by 2a, and that will give us the displacement. So v squared is 0, and then minus 20 squared, so that's minus 400, divided by 2 lots of a, and 2 lots of minus 9.81 is minus 19.62. So if you calculate that, 20.4 meters. Then we just need to get the time. So what we're going to do is calculate the time that it takes to reach its maximum height and then simply double it. So we can use, for that one, you should have realised we can use v equals u plus a2. So the time would be v minus u over a. So the final velocity is 0, minus u would be minus 20, divided by the acceleration of minus 9.81. So that gives us a time to reach its maximum height of 2.038 seconds, or I'll just do 2.04 seconds. So that's the time it takes to go vertically upwards, and then what we need to do is times it by 2 to give us, the total time of flight for the ball to go up and then back down. So you need to times that answer by 2, which would give you 4.077 seconds, or 4.1 seconds. So hopefully you found that okay. Hopefully that was helpful, and thanks for watching. I'll speak to you soon.